Hi, welcome to this video. Now in this video, we're going to do a continuation on multiple equilibria for unbalanced equation. So now this is an example. So now let's have a look on this example, what is expected from us. They want us to calculate the value of Kc for this reaction using the following information. So now this reaction, it is the reaction of the interest, right? This is a reaction of an interest. So we want to formulate using this information, we want to formulate something that looks like this, but at the same time, we want to determine its Kc value. So remember on the previous video, we have learned on how to determine the Kc value. I say to you, when we have two reactions, when you are adding two reactions, you multiply their Kc values, okay? And we have also learned that when you take the, say this is the forward reaction, you want to rewrite this equation starting with the products as the reverse reaction. You're going to take the reciprocal of your Kc value. So those are important elements that we are most definitely going to apply in this example, okay? So now let us start. Now this is how I solve this, okay? I make things much more easier. This is how I solve this. Remember, this is the equation of interest. On the reactant side, we want N2O2. So we go to our equations. Where is N2O2? N2O2, it is only found on this reaction. But the problem is N2O2, it is on the product side. We need it on the reactant side. So to rewrite this, we're going to have to rewrite it in a form that this N2O, it is on the reactant side. So that means I'm going to reverse this equation. I'm going to write this equation in a form of reverse reaction, not the forward reaction. So that means I'm going to say 2N2O, right? I'm going to have 2N2 plus O2. This is the same equation, but this is the reverse reaction of this forward reaction. And then the Kc value for this equation, the Kc value for this equation is going to be how much? It's not going to be the same, remember? It's going to be the reciprocal of this. So that means it's going to be 1 over 1 comma 2 times 10 to the power negative 3. So when I punch this on my calculator, 1 over 1 comma 2 times 10 power negative 35. And this is what I get. On my calculator, I get 8,3 times 10 to power 34. Okay. All right. This is the reciprocal of this. It's 1 over 1 comma 2. You'll get this on your calculator. Now, we managed to get our N2O on our reactant side as N2O. It's our interest. Now, the another thing is, this is what is happening in this equation. This equation, we want to get O2 on our reactant side. Which equation has O2 on our reactant side? It is this equation, right? This equation has O2. Again, this equation, it has nitrogen gas, right? And we want to get rid of nitrogen gas because we do not have formation or addition of nitrogen gas on this chemical reaction. So this nitrogen gas is supposed to cancel off with this nitrogen gas when I add this reaction and these two reactions. So how am I going to rewrite this equation? I'm going to multiply it by 2. That's the first thing, right? And I'm going to write it as it is because I can see that my oxygen, it is already on the reactant side. I'm going to multiply the whole equation by 2 because I want to get rid of nitrogen gas so that it can cancel with that 1. So this multiplied by that is going to be 2N2 plus 2 multiplied by 2. It's going to be 4O2. And therefore, my reaction is going to be 2 multiplied by 2. It's going to be 4N O2. The Kc value will also be multiplied by 2. What you do, you also affect your Kc value as well. So the new Kc value in this case, this one, the new Kc value as well is going to be equals to how much? So I'm going to say on my calculator 4,1 to the multiply by 10 to the power negative 9 multiplied by 2. I multiply that by 2 as well, and then I get 8,3 times 10 to power negative 9. This is what I get. Okay, so now I am going to add these two equations together, right? I'm going to add these two equations together. Now let's add them. So when I add these two equations together, I can see that I have 2 nitrogen gas on the right hand side of this equation. I have 2 nitrogen gas on the left hand side and on the right hand side. So this is gonna cancel with that one. And if I'm gonna transpose my oxygen to add with this oxygen to the other side of the equation, it's gonna be -1. So this, I'm gonna move it down over here, and then when I transpose this one over there, it's going to be 4 subtract 1. These are the like terms, right? Mathematics, this is algebra. I'm going to have 302, and therefore this one I'm just going to down it because that's the only one that is left on the side of the equation, which is 4NO2. Now, what is the new Kc of this equation? Remember, we multiply these two together, right? We multiply these two together. We do not add them. Remember, we did this in a previous video, in the previous lesson. So I'm going to say, sorry, here it's supposed to be 2, not 3. So I'm going to say 8,2 times 10 to power -9 multiply by 8, let me do my bracket, 8, 3 times 10 to power -34. So it's now positive. It's now positive because we took the reciprocal, positive 34. And then we get, with if my calculations are correct, we get 6,8 times 10 to power 26 as the Kc value of this equation. Remember, we got this Kc by multiplying this Kc with that Kc because we added two equations. For the fact that we added these two equations, we multiply these Kc values to get this. Right? Now, let us go back to what we are looking for. So far, we are happy that we have N2O and oxygen gas on our reactant side. But on our product side, we need N2O4. We do not need NO2. So this is the equation that we never utilized, right? So that means we're going to utilize this equation now. So in order for us to utilize this equation, remember we want N2O4 as our product. But we can see that from this equation, we have N2O4 as our reactant. So that means we're going to have to swap everything, right? We're going to have to swap this equation over there. And we're going to have to multiply it by 2 so that we can have 2 over here, which is what we are looking for. We do not need only 2, but let's swap it first. So taking this equation, we're going to have 2NO2, right? Given this equation, N2O4. But now, what's the Kc value of this equation? It's no longer this Kc value. We're going to take the reciprocal of this again because we wrote this equation in a reverse form. This is the forward form of the reaction. The reverse form of the reaction will be the reciprocal. Will also take the reciprocal of that. So on my calculator, I'm going to say 1 divided by 4,6 times 10 to power -3, and therefore I get my Kc value here. I get 217,39. I'll just write 39 to do the small places. Okay, this is the Kc value of this new equation. Now the very same equation, remember, I have to add this equation to this equation, right? Because this is the third equation that I determined from the addition of these two reactions. So this reaction, remember, I'm looking for 2 over here. So that means I'm going to have to multiply the whole equation by 2. So if I decide to multiply the whole equation by 2, right? If I decide to multiply the whole equation by 2, let me multiply it over here. If I decide to multiply the whole equation by 2, now I'm going to have 4 NO2 and here I'm gonna have 2 multiplied by 2 is 4, and then 2 multiplied by 1 is gonna be 2 N2O4. Remember, the Kc value will also be affected. I'm gonna have to multiply the Kc value as well by 2, 2,17,39 multiplied by 2, and therefore I get 4, 3, 4, 7, 8. Now, this is what I'm looking for, 2N2O4, which is this. Now I can add this equation with this equation. Let's add them together. So we have 2N2O plus 3O plus 3O2 to give what is the equation? 4NO2. And the Kc for this one is gonna be how much? It's 6,8 times 10 to power 27, right? 26, so 26. And therefore for this equation, we're gonna have 4NO2. It's gonna give us 2N2O4, and therefore here our Kc value is gonna be 434,78. And therefore now let's add two reactions. Now let's add these two reactions. When we add them together, this, okay, now this, we have 4NO2, we have 4NO2, this is going to cancel with this, and therefore nothing cancels, we just add. So this is gonna be 2N2O plus 3O2, and therefore this is gonna give us what? It's gonna give us 2N2O4. Now, how do we determine the Kc? I don't have enough space over there. I'll just utilize this part. So the Kc of the whole expression, remember, we multiply these two together, right? So the Kc is going to be 434,78 multiplied by 6,8 times 10 to power 26. And then we get that our Kc value becomes 2, actually it's 3. But let me round it to 2 decimal places. It's gonna be 2,9 6 times 10 to the power of 29. So now this is the equation of interest. We managed to form 2N2O and 3O2 and the 2N2O4. So we managed to form this, and this is the final answer, and therefore this will be our chemical. This will be our the value of Kc for this reaction over there. Hope that was helpful.